Welcome to qnawire.
So in this problem, we are given the initial velocity of 0 meters per second, a final velocity of 5 kilometers per second, which is equivalent to 5,000 meters per second, and a distance traveled of 4 meters. For part A, our unknown is the acceleration, and since the acceleration is constant, as it tells us, we can use the kinematic equations. I'm going to use this kinematic equation, which tells us that v squared is equal to v naught squared plus 2 times the acceleration times the distance traveled. The distance traveled is known, it is equal to 4, and so 4 times 2 gives us this 8 here. V naught is 0 because of this, and so that term goes away. And v is 5,000 meters per second, and so we square that and then equate it to 8 times the acceleration. When we plug this into our calculator, we get that the acceleration is 3,125,000 meters per second squared. Now we need to convert this to G's because the problem asks for it in both meters per second squared and in G's. To do that, we note that a G is 9.8 meters per second squared. So if we take this number and divide it by 9.8, we figure out how many G's are in this. When we do that, we get that the acceleration is also 318,877 G's. And these two things combined are the answers to part A. Part B asks for the time. And to get this, I use another kinematic equation, that V is equal to V naught plus A times T. Now V naught is 0, and A was calculated in part A as 3,125,000. And so plugging in 5,000 for V, that big number for A, and then solving for T, I get a T value of 0.0016 seconds. Part C is all about whether or not we can rule out the hypothesis given the large acceleration we calculate in part A. We're also told that bacteria can survive 450,000 Gs, and since 450,000 Gs is still higher than our calculated acceleration part A, we know that this acceleration is not large enough to kill all the bacteria, and so we cannot rule out the hypothesis, and that's the final answer.